All right, part B is asking you to find the integral of this expression. And this is actually a really rich problem because we're actually doing the second part of the fundamental theorem of calculus in part B. So we're going to do the integral from 3 to 5 of 2 times f prime of x plus 4. And so we need to take an antiderivative of 2 times f prime. We know that constants multiplied can just be pulled out. So 2 times the antiderivative of f prime, well, would be f. And then the antiderivative of 4 would be 4x. And then we'll evaluate that from 3 to 5. And so we're going to plug in the 5. So 2 times f of 5 minus 4 times 5 minus 2 times f of 3 plus 4 times 3. And f of 5 is 0, so we have negative 20 minus 2 times f of 3 is, f of 3 is going to be, oh, they gave it to me. So that's good news. 3 minus root 5. And then minus 12. This would be an acceptable answer. You don't have to go any further than that. And I would recommend that you don't, because if you make a mistake and you go further, then you don't get full credit. But that's part B.